Hello, hello, hello. Long time no see to all folks on YouTube. My name is Kashvi, and tonight we're going to be exploring SQL together. Um, those of you familiar with my style from earlier streams, you know I'm going to be doing 25-minute Pomodoro followed by a 10-minute break, and then we come back and repeat. Um, so today we're going to check out sqlbolt.com, sqlzoo.com, and maybe even W3's SQL content. Other than that, that's pretty much what's on plan. If you have any questions, comments, please leave it in the chat, and I'll get back to you as I'm streaming. Cool, I think we're ready to go. Just had to adjust my microphone. I was hearing the monitor, the echo. Alright, so let's start the clock. And it's not starting, is it? It's been a while. Let's see. Can I fix this real quick? Alright. This is not working today. What I'll do is just have a timer, 25 minutes on Google. Let's do it. Alright. SQLbolt.com. What do we got here? Welcome to SQL Bolt, a series of interactive lessons and exercises designed to help you quickly learn SQL right in your browser. That is very helpful because if what they say is true, we're not going to need to install and configure and build databases and then query them and populate these databases. What is SQL? Structured query language. Language designed to allow both technical and non-technical users to query, manipulate, and transform data from a relational database. And due to simplicity, SQL databases provide safe and scalable storage for millions of websites and mobile applications. So they just dumped a couple of definitions here, and the jargon that I wish they could have expanded on for folks getting into it is what do they mean by relational database. But if you Google it, I think it's just tables and how they're related to each other, pretty much. Alright, there are many popular SQL databases, including SQLite, MySQL, Postgres, Oracle, SQL Server. All of them support the common SQL language standard, which is what this site will be teaching, but each implementation can differ in additional features and storage types it supports. Oh, here we go. They do define what relational databases are. Nice. Before learning syntax, it's important to have a model for what a relational database actually is. Very good. A relational database represents a collection of related tables, two-dimensional. Each of the tables is two-dimensional, meaning there's a row and there's a column, X, Y. Each of the tables are similar to an Excel spreadsheet with a fixed number of named columns. They're called the attributes or properties of the table, and any number of rows with data. Alright, then there goes an example table. If the Department of Motor Vehicles had a database, you might find a table containing all the known vehicles that people in the state are driving. This table might need to store the model name, type, number of wheels, and number of doors to each vehicle, for example. In such a database, you might find additional related tables containing information such as a list of all registered drivers in the state, the types of driving licenses that can be granted, or even driving violations for each driver. By learning SQL, the goal is to learn how to answer specific questions about this data, like what types of vehicles are on the road, have less than four wheels, or how many models of cars does Tesla produce, to help us make better decisions down the road. I think I like what they wrote here. The goal is to learn how to answer specific questions about this data. When I first encountered SQL like 10, 12 years ago, I thought it was more programming. Like I thought I had to build, well, yeah, I had to build tables, but I was thinking more like it was some sort of an object-oriented programming language, and I had to make classes and stuff. So I guess I didn't take it that seriously, but SQL actually is just best to learn SQL in the best way, in my opinion, is to have questions, and you develop the SQL skills by, you know, figuring out how you're going to ask the database the questions, because all you're doing is having a conversation with the database and asking the database about specific things. So I hope this site helps us do that. I hope, as they promised here, right in your browser, I hope there's a bunch of databases that are on the back end that we can query and learn uh, how to write those queries and everything else. Alright, by learning SQL, the goal is to learn how to answer about the lessons. Since most users will be learning SQL to interact with an existing database, the lessons begin by introducing you to various parts of an SQL query. I slipped right there. I said SQL, SQL, Squeal. I think most people prefer SQL, SQL. Whatever floats your boat, I think. Probably not good advice, but more often than not, it's SQL, SQL. Those are probably the two groups of people. Don't say squeal. The later lessons will then show you how to alter a table and create new tables from scratch. Each lesson will introduce a different concept and with an interactive exercise. Go at your pace and don't be afraid to spend time experimenting with exercises before continuing. I like this. If you happen to be familiar with SQL already, you can skip ahead using the links in the top right, but we recommend you work the lessons anyway. By the end, we hope you will be able to have a strong foundation for using SQL in your own projects and beyond. Let's check out. Oh, here we go. Here's the curriculum. Lesson 1, SQL Queries 101, select queries with constraints, filtering. The joins is probably where the fun begins. Note about nulls, queries with expressions, aggregates, insert, update, delete, create, CRUD operations. Alright, 19 lessons, not bad. Alright, let's get started with lesson 1, writing SQL queries, and we have 18 minutes. Okay, lesson 1, select queries 101. To retrieve data from a SQL database, we need to write select statements, which are often colloquially referred to as queries. Query in itself is just a statement which declares what data we are looking for. I also need to turn Do Not Disturb on. If a message comes up or stuff, my apologies. To retrieve data from a SQL database, we need to write SQL select statements, which are often colloquially referred to as queries. A query in itself is just a statement which declares what data we are looking for, where to find it in the database, and optionally how to transform it before it is returned. It has specific syntax though, which is what we are going to learn in the following exercises. Yeah, sometimes you just have to think of yourself as a Harry Potter wizard with SQL. So you're pretty much writing spells on what you want returned from a giant haystack. Anyway, as we mentioned in the introduction, you can think of a table as SQL as a type of an entity, and each row in that table has a specific instance of that type. This means that the columns would then represent the common properties shared by all instances of that entity. Alright, let's go through that again. Think of a table in SQL as a type of an entity. Each row in the table has a specific instance of that type. This means that the columns would then represent the common properties shared by all instances of that entity. So table is an entity. Each row is a specific instance of that entity of that type. Table is a dog. A row could be a pug, a beagle, a chihuahua, a bulldog. Color of fur, length of table. And given a table of data, the most basic query we could write would be one that selects from a couple of columns of that table with all the rows. So here, basic example of what a select statement would look like is select column, another column. The dot dot means you could select as many columns as are provided, and then you have to specify from where do you want to get these columns from. So the table name comes after the from. The result of this query will be a two-dimensional set of rows and columns, effectively a copy of the table, but only with the columns that we requested. If you want to retrieve absolutely all the columns of the data from a table, we can then use asterisk shorthand in place of listing all the columns names individually. Alright, this is select star from table, means give me all the columns from this table. So if you ever want to just get everything, you don't want to specify one or two columns, just give me everything from the table, always use a star. This query in particular is really useful because it's a simple way to inspect a table by dumping all the data at once. If you have a giant database, you don't want to do that. It'll take forever. Especially if it's a slow computer or something. But you know, this is going to be a toy database. And dumping it all at once is not going to be a big deal. We will be using a database of data about some of Pixar's classic movies. Oh, cool. For most of our exercises. The first exercise will only involve the movies table, and the default query below currently shows all the properties of each movie. To continue on to the next lesson, alter the query to find the exact information we need for each task. Okay. So we got task 1, find the title of each movie. Okay. Alter to query to find the exact information we need for each task. First task, let's see. Alright. Title. Let me first run this. How do you run this? Shift. Okay, the UI instructions. Alright, let's just try. Oh, it's telling me stuff. Select title from movies. Oh, it's just gonna automatically do it. Nice. Select star from movies. Select director. Select title and director. And if I want to do multiple columns, if you remember, it was just comma, and you had the second one. And if you notice, you don't have to worry about case sensitivity, or do you? Nope. But I think common practice is to have the special words for a SQL called reserved keywords capitalized, and your stuff not capitalized. Year for movies. Find all information. That was pretty cool. That was nice. Let's do reset. Select ID from movies. Select, what was it, title from movies. Can I do where? Nope. We'll get to that later. I forgot how to do that, but it's there. Cool. Oh, here we go. Where is next? What was I trying to do? So it would have been select. Okay. Lesson 2. We got 10 more minutes. Queries with constraints. Some of you might be wondering what constraints are. Maybe English is not your first language. Constraints. Continue. Limitations or restrictions. So queries with limit restrictions. Now we know how to select for specific. Now we know how to select for specific columns of data from a table. But if you had a table with 100 million rows of data, reading through all the rows would be inefficient and perhaps even impossible. In order to filter certain results from being returned, we need to use a where clause in the query. The clause is applied to each row of data by checking specific column values to determine whether it should be included in the results or not. The where clause is applied to each row of data by checking specific column values to determine whether it should be included in the results or not. So we have select column, another column, comma, from where are you selecting these columns from this table, where, and then you define a condition. And if you have multiple condition, you could be like where this condition and that condition. If you use and, they both have to be true, and then it'll display. If you use or, one of the two has to be true, and it'll display. If you're not familiar with this, it's pretty much review Boolean logic. You know, if you ever done it like true or false equals true, true and true equals true, true and false equals false, false or false is false, false or false is true. Is that right? Truth tables. False or false is that false or false equals false. Yep. False or true equals true. True or false equals true. True or true equals true. Yeah, for the or, there's one false. If there's two false, it's false. Or and, if it's one false, it's false. If there's any false, it's false. Why does... Oh, it's a reference. What else they got here? Side track. Nothing. 7 more minutes. Alright, let's get through this. More complex clauses can be constructed by joining numerous and or logical keywords. And below are some useful operators that you can use for numerical data. Column name not equals to 4. Oh yeah. Equal, not equal, less than or equal, greater than or equal. Oh, between and. That is cool. Not between and. Oh, nice. In addition to making the results more manageable to understand, writing clauses to constrain the set of rows returned also allows the query to run faster due to the reduction in necessary data being returned. That's good. As you might have noticed by now, SQL doesn't require you to write the keywords all capitalized, but as a convention it helps people distinguishing SQL keywords from column and table names, and makes the query easier to read. Nice. Alright, using the right constraints. Find the information we need from the movies table for each task below. Alright, I need to delete this. Alright, find the movie with a row ID of 6. So we're writing a select query. Select, what am I selecting? Find the movie with a row, select ID from movies. Right, where ID equals 6. Nice, right? Why is it not? Oh, select all. Nice, okay. So before when I did this, I was asking for it to just return the ID. But here, I wanted the whole row. That's why the star is better. It's the Incredibles. Alright, next one. Find the movies, multiple, released in the years between. Ooh, between. Nice, I like what they're doing. They're already telling you, let's try some cool keywords. Alright, select star from movies where year. Okay, let's go back and see how between works. So column name, column name and then between. Between number and that. Okay. Alright, so select. So it'll be between. I need this. 2010. Does that work? Nope. From movies. It's a little left. Does that work? Nope. Let's go back and check this out. Okay, where condition select star from movies where year between 2000 and 2010. Yes. Give me that dopamine hit. That always feels nice. let me just review that dopamine hit. What just happened? I was struggling a little bit because I thought, where does the where clause go? I also was doing it without the where keyword. But okay, so you want to select all the columns from the movies table, where then you specify what your condition, what we're trying to filter. So here it's gonna be year, the year, and it's gonna be between 2000 and 2010. Let's do 2001, 2002, 2003, 4, 5, 6, 7, 8, 9, 10, 10. Nice. Alright, next one. Find the movies not released in the years between 2000 and 2010. Alright. Once again, we're selecting all the columns from the movies table where year is the column that we're going to use to filter things. Year. So we did between, right? Can I just add not? Yes. Not between. Column name, not between 1 and 10. Good stuff. Semicolon. I'm actually enjoying this tutorial. Props to sqlbolt.com. How much time do we have? We have 18 seconds. Okay, let's just finish this one and we'll take a break. Find the first 5 Pixar movies and their release year. 5 Pixar movies. First 5 Pixar movies and their release year. How would we do that? One, two, three, four, five. So it should be Toy Story, Bugs Life, Toy Story 2, Monsters Inc., Finding Nemo. Do we just do ID? Let's try that. Just a query that just returns ID between 1 and 5. So select star from movies where ID between 1 and 5. Yep. Ding ding ding. Alright, timer's up. What this means is we're going to take a 10-minute break. During this break, I welcome you to drink a little coffee if you want, get some water. Water's really good because it'll help with the eyes. You don't want dry eyes. Start seeing blurry things. Dehydration is not good. Or you could do some exercise, walk around, jumping jacks. Whatever it is, just get away from the computer. Or open up Instagram and get your dopamine fix from there. Whatever you want to do. But after that 10 minutes, come back and we're gonna attack this more and focus. Alright? See you then. Alrighty, let's get back to it. Whoops. 25 minutes on the clock. Guess they don't really make a difference. Let's get going. Continue. I think you guys can hear me alright. Lesson 3, Queries with Constraints Part 2. When writing where clauses with columns containing text data, SQL supports a number of useful operators to do things like case-insensitive string comparison and wildcard pattern matching. We show a few common text data specific operators below. Case-insensitive string comparison. What do you think that means? Case-insensitive string comparison. Well, you probably will think, we're going to compare two strings. What are strings? Strings are like words or sentences. And we're going to be comparing them without caring about whether Q is capital or C is lowercase. We're just going to compare. Wildcard pattern matching is a little more complicated. Alright, so let's check them out. Equal operator is case sensitive exact string comparison. Oh, notice a single equals. So if a column has ABC, case sensitive, lowercase a, lowercase b, lowercase c, then it'll match and say, yeah, that's true. Where's the case insensitive? Case insensitive, column name like. So you can use the like operator if you want to find both a, b, and c lowercase or a, b, and c uppercase. One of those two. Return it to me. Case sensitive exact string inequality operator comparison. Case sensitive exact string inequality comparison. So not equal or not equal. Is this not equal? I like this one more. This is more common in many different programming languages. Case insensitive exact string comparison like operator. Case insensitive is not like. Column name not like ABCD. Okay. This is a modulo operator. Percent assign. Used anywhere in a string to match a sequence of 0 or more characters. Well, modulus from the other one, I don't know what they're calling it here. Used anywhere in a string to match a sequence of 0 or more characters. This is the pattern matching part. So before percent sign, at percent sign, it's going to match anything that has AT before, after, in betweens. So if bats has AT inside, at has AT, attic is before, cat is at the end. If there's AT in any of these words, it'll return it. Underscore, used anywhere in a string to match a single character, only with like or not like. Column name like AN matches AND, but not AN. In string exists in a list, column name in ABC. String does not exist in a list. Column name not in TEF. All strings must be quoted. So notice everywhere here, you know it's a string when there's double quotes. So the query parser can distinguish words in the string from the SQL keywords. We should note that while most database implementations are quite efficient when using these operators, full text search is best left to dedicated libraries like Sphinx or Lucene. What are those? Nice. This is probably what you love to use. Sphinx. These libraries are designed specifically to do full text search, and as a result are more efficient and can support a wider variety of search features, including internationalization and advanced queries. Alright, here we go to the exercise. Here's the definition of a query with a where clause again. Go ahead and try to write some queries with operators above to limit the results to the information we need in the text below. Find all the Toy Story movies. Okay. Find all the Toy Story movies. Select everything from movies where title like Toy Story. Title like Toy Story. Title like Toy Story. What was that underscore thing? Toy. Matches and, but not and. So this one's gonna find everything that's not like Swift Story. Alright, find all the movies directed by John Lasseter. Select star from movies where director equals John Lasseter. Yeah. It's gonna be an equality because we want exactly that name. But if we didn't know how to spell his name, John can be that. John Lasseter, okay. Oh, everyone that's not John Lasseter. Everyone doesn't have John. Not. Find all the Wall-E movies, probably. Okay. Select star from. By the way, I keep deleting the queries because I just want to Keep getting some practice, muscle memory practice from movies where title like, oh, this is probably where the dash comes in. Nope. Did I do it right? Oh, it's dash. I'm trying to figure out how does that dash thing work. Anyway, I could just do the parentheses. Yep. Wall E and wall G. Nice. 15 minutes left. Lesson 4. Filtering and sorting query results. Even though the data in a database may be unique, the results of any particular query may not be. Take our movies data table for example. Many different movies can be released the same year. In such cases, SQL provides a convenient way to discard rows that have duplicate column value by using the distinct keyword. Nice. A convenient way to discard rows that have duplicate column value. So just give me one. Convenient way to discard rows that have duplicate column value. Distinct keyword. So select, instead of everything, select distinct, and then you do column, another column, etc. From table where conditions, etc. Since the distinct keyword will blindly remove duplicate rows, we will learn in a future lesson how to discard duplicates based on specific columns using grouping and the group by clause. Nice. Ordering results. Unlike our neatly ordered table in the last few lessons, most data in real databases are added in no particular column order. As a result, it can be difficult to read through and understand the results of a query as the size of a table increases to thousands or even millions of rows. To help with this, SQL provides a way to sort your results by a given column in ascending or descending order by using the order by clause. Alright, so what are we taking away from this? Most data in real databases are added in no particular column order. And in order to order it, we use the order by clause. So far we've been selecting columns from which table, providing conditions, then at the end we can say order by, pick a column, ASC is for ascending, DSC is for descending. When an order by clause is specified, each row is sorted alphanumerically based on the specified column's value. In some databases, you can also specify a collation to better sort data containing international text. Each row is sorted alphanumerically based on the specified column's value. So order by column, so this column, all the values underneath this column is sorted alphanumerically. Nice. Limiting results to a subset. Another clause which is commonly used with the order by clause are the limit and offset clauses. Okay, they're really just packing it in, giving you a lot here, which are a useful optimization to indicate to the database a subset of the results you care about. The limit will reduce the number of rows to return. The optional offset will specify where to begin counting the number of rows from. Oh, nice. So it's again, we know how to select columns from which table, what are the conditions to look for, how do you order it. And now we're saying limit number of rows, I guess the maximum number of rows, and count from where to begin counting. If you think about websites like Reddit or Pinterest, the front page is a list of links sorted by popularity and time. True. And each subsequent page can be represented by sets of links at different offsets in the database. Using these clauses, the database can then execute queries faster and more efficiently by processing and returning only the requested content. Did you know? If you're curious about when the limit and offset are applied relative to the other parts of a query, they're generally done last after the other clauses have been applied. We'll touch more on this in lesson 12, order of execution, after introducing a few more parts of the query. Exercise. Here we go. There are a few concepts in this lesson. But all are pretty straightforward to apply. To spice things up, we've gone and scrambled the movies table for you in the exercise to better mimic what kind of data you might see in real life. This is good. Very, very good. Try and use the necessary keywords and clauses introduced above in your queries. Nice. Good stuff. List all directors of Pixar movies alphabetically without duplicates. Okay, keyword they said without duplicates. So select distinct director from movies. Select star. Nope. Oh, I gotta sort it. Sort was group by, order by. Try to select distinct everything. Order by director. Without duplicates. Okay, so there's duplicates right now. List all directors. So they just want directors, they don't want anything else. Yeah. That was it. Order by director I didn't really have to do. I guess it's by default ascending. But let's do descending. Order by director DSC. DSC is the other very nice. Let's go on to the next one. List the last 4 Pixar movies released. Order from most recent to least. Okay, so let's. The plan is to get everything and then order by year, descending. Yep, let's try that. Select star from movies. Order by year. DSC. No. List the last 4. Okay, last 4. What was that? Limit. 4. Nice. List the first 5 Pixar movies sorted alphabetically. Select star from movies. Order by. Year. Limit 5. List the first 5 Pixar movies. 1, 2, 3, 4, 5. Sorted alphabetically. Order by Mm, filtering. Distinct. Or by title. So I can do both. Limit 5. Oh, wait. I didn't have to do anything with the year because they just want alphabetical order. First 5 alphabetical ordered movies. Okay. So once again, movies, order by title. Limit 5, offset 5, offset 5. So show me the 5 starting from the 5th one, 6th one. Let me see. Limit 10. So it's gonna be 1, 2, 3, 4, 5. Should be Monsters University of Toy Story. Nice. Very good. We've got 3 more mats before our next break. What are we learning here? A SQL review. Oh, it's a review. Nice. You've done a good job getting to this point. Now that you've gotten a taste of how to write a basic query, how long are these things? Was it 25 minutes? Feels so quick. How long have I been streaming for? I've been streaming for 1 hour. Yes. This was the second Pomodoro, okay. Alright, this thing's gonna go off, but we're gonna just go up to here and then take the break. You've done a good job. Yes, we've done a good job getting to this point. Now that you've gotten a taste of how to write a basic query, you need to practice writing queries that solve actual problems. Damn. So let's review the select query. Select column, another column from my table where conditions, order by, limit, offset. Nice. In the exercise below, you'll be working with a different table. Thank you. This is exciting. This table instead contains information about a few of the most popular cities of North America, including their population and geospatial location in the world. Did you know positive latitudes correspond to the northern hemisphere and positive longitudes correspond to the eastern hemisphere? Since North America is north of the equator and west of the prime meridian, all of the cities in the list have positive latitudes and negative longitudes. Try and write some queries to find the information requested in the task below. You may have to use a different combination of clauses in your query for each task. Once you're done, continue on to the next lesson to learn about queries that span multiple tables. Alright, what are we doing? First one, let me just pause this. So I don't want it to go off. Delete that, so okay. So I'm keeping it at the top of the table so I can see the name of the columns. List all the Canadian cities and their population. Select star from North American cities where country equals Canada. population. I'm gonna do city, country, population. Okay, anyway, I got that one right. Order all the cities in the United States by their latitude from north to south. Okay, I'm gonna have to go back and read the thing about the positive negative thing. But alright, select star from North American cities. Where countries equals to states. And now order by latitude. Latitude. Do you see? It's ordered by column. SC LA. Oh, I spelled it wrong. From north to south. Okay, so which one's north to south? Latitudes correspond to northern hemisphere. Longitudes correspond to eastern hemisphere. Okay, I guess it's DSC. Okay. List all the cities west of Chicago. Order from west to east. West of Chicago, okay. Select star from North American cities. Where west of Chicago. Hold on. Positive latitudes correspond to the northern hemisphere. Latitudes, right? Longitudes correspond to the eastern hemisphere. Something with the longitudes, I guess. They're going west. West of Chicago. Where's Chicago? Oh, okay. uh, can I do that? Nope. List all the cities west of Chicago. So I don't want New York or Philadelphia. Country equals the United States. It's between or after. Let's just look at the cheat sheet. Oh, wait a minute. Where longitude greater than -87. Oh, yes, the end. Oh, less than. Ordered by from west to east. I think it's west to east. Oh, okay. West to east. List all the city west of Chicago. So not including Chicago. Okay, west of Chicago is gonna be 1, 2, 3. Oh, I'm including United States. There we go. Got it. I was leaving out the Mexican cities. List the 2 largest cities in Mexico by population. Star from where country equals to Mexico and order by population limit 2. Is that not? How many cities are there? There's 3. Mexico City has 8.5 million. 1 point. Okay. Descending. Limit 2. Nice. List the 3rd and 4th largest cities by population in the United States and alright. Let's look star from country equals to United States. Order by population. Descending. Limit 2. Offset 3. 2. That was fun. That was fun, and I learned stuff. That was fun. What's next? Multi-table queries with joins. Ooh, we're getting to the good stuff. How long have you been streaming? We've been streaming for an hour and 16 minutes. So we didn't check out these things, but I think SQL Bolt is the winner. We did 2 sessions so far. I've been looking for something like this for a while. Let's do one more session, and then we'll call it a day for today. What time is it? 7? Yeah, it's Monday night. Yep. One more session. So let's take a break, and then we'll wrap up. We'll try to go to lesson 6. Actually, 6 and 7 go together. So maybe we could do 6 and 7. Alright, but first let's take a break. See you after. So go take a walk, get something to drink. Just get away from the computer. See you. Alright, back at it. Let's start the clock. And let's take care of business. SQL bolt. Let's close these two out. Multi-table queries with joins. I'm excited about this. Can't believe how painless it's been. Up to now, I've been working with a single table, but entity data in the real world is often broken down into pieces and stored across multiple orthogonal tables using a process known as normalization. The link takes you to the Wikipedia article, database normalization. Probably goes through zero normal form, first normal form, second normal form, third normal form. Yeah. Have a read for that on your own time. Should be fun. It's a little complicated at first, but after a few times reading it, it makes sense. Okay. All that stuff is called normalization. Database normalization is useful because it minimizes duplicate data in any single table. Yep. Minimizes duplicate data in any single table. Normalization minimizes duplicate data in any single table. Normalization allows for data in the database to grow independently of each other. As a trade-off, queries get slightly more complex since they have to be able to find data from different parts of the database. Performance issues can arise when working with many large tables. In order to answer questions about an entity that has data spanning multiple tables in a normalized database, we need to learn how to write a query that can combine all that data and pull out exactly the information we need. So here we go, lesson 6, we're becoming, um, more mature database developers, database administrator. Alright, multi-table queries with joins. Tables that share information about a single entity need to have a primary key that identifies the entity uniquely across the database. One common primary key type is an auto-incrementing integer because they're space efficient, but it can also be a string hashed value so long as it is unique. Using the join clause in a query, we can combine row data across two separate tables using this unique key. The first of the joins that we will introduce is the inner join. Select query with inner join on multiple tables. So we did the select clause from clause, then it's inner join another table on this table's ID column and the other table's ID column, where the conditions order by limit. These two, 1, 2, 3, 4, 5. The 5 are old, these two lines are new. Okay. The inner join is a process that matches rows from the first table and the second table, which have the same key, to create a result row with the combined columns from both tables. Probably have to study that for a couple of times. After the tables are joined, the other clauses we learned previously are then applied. Did you know? You might see queries where the inner join is written simply as a join. These two are equivalent, so inner join and join are the same. But we'll continue to refer to these joins as inner joins because they make the query easier to read once you start using the other types of joins, which will be introduced in the following lessons. Alright, so while they're equivalent, do the same thing. They're saying we're going to keep doing inner joins to make sure as we're learning the different types of joins, we can just distinguish between all the joins and what they do. We've added a new table, nice, to the Pixar database so that you can try practicing some joins. The box office table stores information about the ratings and sales of each particular Pixar movie. The movie ID column in the table corresponds with the ID column in the movie's table 1 to 1. ID column. So ID1 is Toy Story. Rating is 8.3. Alright. Find the domestic and international sales for each movie. Alright, let's read what join is. Combine row data across two separate tables. Inner join on a table. Okay. 5 for each movie. Each movie has ID. Alright. Select star from movies. I guess we want select title. Is that domestic? Domestic sales, international sales. Size. Right. Domestic sales, international sales is the other one. Do I write that in that first one? Yes, from column, another table column. So I have column from this one, another column. Okay, from movies. Inner join, another table. Inner join. What's the other table's name? Box office. Nice. Okay. Why are they all? Oh, there's gonna be Toy Story for domestic sale, Toy Story for international sale. That's why. Okay. On on movies dot title, movies dot ID, box office dot ID. Is that right? Equals on, not a comma, where order by. Maybe it's just all of them. Movies ID. Oh, movie ID. That's what it is. Box office dot movie ID. So that's where I was messing up. I was doing movies.id, box office movie ID, but I noticed that this ID was not the same as this other ID. We sort by movies ID. Show the sales numbers for each movie that did better internationally rather than domestically. Show the sales number. Okay, again, select show the sales number. Title, domestic sales. International sales. From movies. Inner join. Box office, something, right? Box office. On movies.movie. Movies.movie. Where turn oh, it already gave me. That was it. Let me switch this up. International did better than order by Toy Story 3 did 648 million. 415 million. List all movies by ratings in descending order. What's is that a join thing? Oh, ratings were there. Select star. Select star from movies. Inner join on. Inner join on. Inner join. Box office on movies.id equals to box office dot movie ID. Did I get all of them? Yes. That's too many rows. Just title, rating, descending order. Order by rating. DSC. Cleaner. I would do rating, title, year, director. Look at that. This would make selecting will be so much easier instead of going through Rotten Tomatoes page after page after page. Alright, that finishes up there. We have 10 more minutes. So let's actually go to outer joins. We did the inner join. Let's find out what outer join is. Lesson 7, outer joins. Depending on how you want to analyze data, the inner join we used last lesson might not be sufficient because the resulting table only contains data that belongs in both of the tables. The two tables have asymmetric data, which can easily happen when the data is entered in different stages. Then we would have to use a left join, right join, or full join instead to ensure that the data you need is not left out of the results. So select, we know, select from one column, select column from another column. From the first table, you need to enter left, right, full join with the other of the table. Where are you going to join? Column on one, the column with the other. Where conditions, blah blah. Like the inner join, these three new joins have to specify which column to join the data on. When joining table A to table B, a left join simply includes rows from A regardless of whether a matching row is found in B. The right join is the same but reversed, keeping rows in B regardless of whether a match is found in A. Finally, a full join simply means that rows from both tables are kept, regardless of whether a matching row exists in the other table. Matching. Nice, nice. When using any of these new joins, you will likely have to write additional logic to deal with nulls in the result and constraints. More on this in the next lesson. Did you know you might see queries with these joins written as left outer join, right outer join, or a full outer join? But the outer keyword is really kept for SQL 92 compatibility, and these queries are simply equivalent to left join, right join, full join. In this exercise, you're going to be working with a new table which stores fictional data about employees in the film studio and their assigned office and buildings. Some of the buildings are new, so they don't have any employees in them yet, but we need to find some information about them regardless. Since our browser SQL data is somewhat limited, only the left join is supported in the exercise below. Okay. We got buildings, we got employees. Only the left join is supported. Which one's left join? When joining table A to table B, a left join simply includes rows from A, regardless of whether a matching row is found in B. Okay, let's see what we can do here. Find the list of all buildings that have employees. What? Oh, I see. That have employees. Okay. What I want to do is select the list of all buildings. Select building name. You know what, I'll just select star. From buildings, left join on employees. No, left join employees on building name equals to building. Let's do that. Buildings, employees, left join. Oh, I did that. On buildings dot building name equals to employees dot building buildings that have employees. What do we got? Okay, find a list of all buildings that have employees. 1E has employees. I did do the join right. Find list of all buildings. Where years employed is not null. Greater than 0. Oh, that's probably it. I should have name row. Find the list of all buildings that have employees. One E and one W. That's 2. Nope, there's more. Two E does not have employees. Right. What am I doing wrong? Okay, select building name. From the first table, inner join, full join, left join. Left join simply includes a row from A stop. Maybe switch them. Does that work? Huh. Tempted to see the solution, but I don't want to see the solution. Let's start over again. Let's read it up. Inner join we used last lesson might not be sufficient. The two tables have asymmetric data. Okay. When joining table A to table B, a left join simply includes the rows from A, regardless of whether a matching row is found in B. What is the matching row here? It's building. Building name. Okay, select. Oh, here we go. 1W2E doesn't have anything. I need to get rid of 1E. One W is empty. Where employee dot name not null. Yeah, I get that. But why does it not accept? Find the list of all buildings that have employees. Find the list of all buildings. What if it's just building name? to the hell? Select distinct building from employees. What is that? Select distinct building from employees. Unbelievable. Find the list of all buildings in capacity. These guys. Select building name. List all buildings and the distinct employee roles in each building. Select. Manager comes up twice. Find a distinct building names. List all buildings and the distinct employee roles. distinct building name, role, from buildings, left join, employee, on building name equals building. What? Not bad. I think I will need to review the joins more. But that was fun. That was fun. How long have we been on stream? It's a fun 2 hour stream. Nice. 2 hours of SQL. So, good job to all of us. We were able to learn something new and not doom scroll for 2 hours or play fantasy football for no reason. Thanks for joining me today. I hope you have a great evening, morning, afternoon. If you are watching this at a later time, leave a comment and I will get back to you. Leave a question. If you need help, let me know. Thanks for joining me. Peace. Does that thing go on? Yep, there we go. Bye bye.